Okay, now we're going to look at double angles, and this is when we have cos 2x. We have other identities for sine and tan, but more specifically, I'm going to focus on the cos one. Okay, so cos 2x equals to 2 cos x squared minus 1, and that's one property. We have another property that says 1 minus 2 sine x squared. Okay, there's two properties for cos 2x. Okay, and I'll show you how we're going to utilize this into our questions. Okay, but these two things, you must remember them. Okay, must memorize them, okay, because they're used very frequently in our integration questions. So, starting with question 4a, it says express sine 2x squared in cos 2x. Okay, basically what this means, it wants us to write sine 2x squared in terms of cos 2x. Okay, how do we do that? Well, we're simply going to use our double angle identities that I've mentioned just previously. Okay, so starting with cos 2x equals to 1 minus 2 sine x squared. Okay, I chose this one because this one has sine x squared, isn't it? Sine squared, so I chose this one. Okay, so depending on the question, try and identify which identity you would like to use. So I'm using this one. Okay, so I've got my identity. Now what I'm going to do is make 2 sine x squared be the subject. Okay, so simply all I did was move this onto the other side to make it a positive 2 sine x squared, and then move the cos 2x onto the other side. Basically, it's just some algebra. Okay, 2 sine x squared equals to 1 minus cos 2x. So now that I've got that, I'm going to make sine x squared be the subject by dividing everything by 2. Just like this. So this becomes sine x squared, and the right hand side becomes 1 over 2 minus 1 over 2 cos 2x. Alright? So guys, I've got this now. I've got sine x squared, but that's not what I want. Sine 2x squared is what I want. So what I'll do, if I want to have sine 2x squared, I'll multiply the inner function by 2, and then that means I must multiply this by 2 as well. Okay, so I did 2 times 2, which becomes 4x over here. Alright, does that make sense? So basically, if I'm multiplying the inner function of this one by 2, I must multiply the inner function of this by 2 as well. Alright, and that's our simple answer. Have a look, guys. That's our answer to question 4a, and all I've done is use my double angle identities. Alright, so have a look. So I've got sine 2x squared, and I'm going to use that in our part B, because B says, hence find the integral of sine 2x squared dx. Alright, basically we're integrating this. Okay, integration of sine 2x squared, which is what we had in part A. But remember, we found that sine 2x squared equals to this. And guys, the reason why we're actually using double angle identities is because, can you actually integrate that straight away? No, we cannot integrate anything that has a power like that. Okay, especially if it has squared, we cannot integrate it. Okay, so we must cut down the power and then integrate it. So that's why we use our double angle properties, like we did here, in order to get the power as just 1. Okay, so it's not cos squared, it's simply cos. Okay, so therefore, all I'm going to do is integrate this one that I've obtained in part A. Okay, because that is sine 2x squared. Alright, so I've got that, and I'm just going to separate out the integral. So I have integral of half dx minus the integral of half cos 4x dx. Okay, and then plus c. Okay, make sure you always plus c. So let's integrate it one by one. So therefore, half, simply integrate, becomes half x, and this one becomes half, okay, that half, times 1 over 4, which becomes 1 over 8, okay, half times 1 over 4 is 1 over 8, and then the integral of cos x is simply sine x, isn't it? So the integral of cos 4x is simply sine 4x, yeah? And then plus c, of course. That's our simple answer. Okay, that's the answer for question 4b. Alright, so b was actually quite simple. This was the key point. Alright, so have a look, and we'll try a similar question in question 5. So question 5 says, in part A, express cos 6x squared in cos 2x. Okay, So again, it's a similar kind of question. We want to express this expression cos 6x squared in terms of cos 2x. Alright? So what I'll do is start off by using my double angle identity. This time I'm going to use the identity that cos 2x equals to 2 cos x squared minus 1. Okay, I'm going to use this particular one because this has cos squared. Okay, so I'm going to choose this one. So make sure again you use the right property. So I've got that one now. What I'm going to do now is simply make 2 cos x squared be the subject. Alright, simply move -1 over to the other side so it becomes cos 2x plus 1. Okay, so I've got that. Now divide both sides by 2. Okay, because I just want cos x squared, don't I? So divide everything by 2. So I have here 1 over 2. Basically I'm dividing this one by 2. So I'll just put it at the front. 1 over 2 plus half cos 2x. Okay, simply just dividing everything by 2. Okay, now look back to the question, guys. It's actually asking for cos 6x squared, not cos x squared. So if I want to make it to be cos 6x squared, then I'm simply going to multiply this by 6 as well. Okay, so it becomes cos 12x over here. Okay, because 2 times 6 is simply 12. Alright, so do you get that? So, because I've multiplied that by 6, I must also multiply this by 6. Okay, so it becomes 12x. So have a look, guys. I'll rub this off. And that's our answer for part A. So now that I've got that, I'm simply going to do part B, because it says, hence, find the integral of cos 6x squared dx. Alright? Basically, it's asking us to integrate this one over here, cos 6x squared. So, guys, again, it's something to the power of something, power of 2. We cannot integrate that. So we must use our answer in part A. Okay, so I'm simply going to integrate this outcome. So it becomes the integral of half dx plus the integral of half cos 12x dx. Okay? So integrate that, it becomes half integrated is x over 2, or half x basically, plus, now this becomes half times 1 over 12, right? And then the integral of cos is of course sine, so sine 12x plus c, and just simplify that, it becomes x on 2 plus 1 on 24, sine 12x plus c, and that's the answer for question 5. So have a look. Okay. And again, this is the key point, okay? Make sure you understand this very clearly because that's the main point for this part. Alright, so have a look and let's move on. So question 6 says evaluate 2 times the integral of sine 4x squared dx, and it gives us a boundary here between 0 and pi on 4. So let's integrate this, but first, can you see that we've got a square here? Got a power of 2, so we cannot integrate it straight away. So what I'll do is use my double angle identity that cos 2x equals to 1 minus 2 sine x squared. I'm going to use this one because this one is sine squared. Okay, so I've chosen that one. Now I'm going to do my usual thing as I did in question 4 and 5. I'm going to make 2 sine x squared be the subject first of all. Okay. So 2 sine x squared is simply 1 minus cos 2x, right? So therefore now, I want to make sine x squared be the subject, so I'll divide both sides by 2. So I have half times 1 minus cos 2x. But look guys, it says sine 4x squared, not just sine x squared. So what I'll do is multiply that by 4. So I have sine 4x. So it becomes sine 4x squared, and that would be equal to half times 1 minus cos 8x, because I'm also multiplying this one by 4. Okay, so if I multiply that one by 4, we get 8, since I multiplied that one by 4. Okay, so have a look. But guys, look at the question. It's asking us to integrate 2 times sine 4x squared, isn't it? So what I might do is just multiply both sides by 2. So I get 2 sine x 4x squared equals to 1 minus cos 8x. The half actually becomes eliminated since I'm multiplying by 2. Okay? So I've actually got 2 sine 4x squared, which is actually the question. Okay, so what I'll do now that I've got that, I'm going to actually do the integral of 1 minus cos 8x dx. That's what I'm going to do. Okay, make sure guys you don't put the 2 out the front, because this thing represents 2 sine 4x squared, so I've actually included the 2 into that. Okay, so make sure you don't put the 2 out the front. The whole thing is the integral of 1 minus cos 8x dx. Okay, so all I need to do now is integrate this one. Okay, it's going to be pretty simple. So if I integrate that, integrate 1 becomes x, integrate cos 8x becomes 1 over 8 sine 8x, right? And it has a boundary between 0 and pi on 4, so now I'm going to substitute those values in. So I'll sub those in. So x is pi on 4, so I put pi on 4 minus 1 over 8 times sine 2 times pi, okay, because 8 times pi on 4 is 2 pi, isn't it? And then minus 0. If I put 0 into here, it becomes 0. Sine 0 is 0, so it all becomes 0 anyway, so I'll just make that into 0 itself. So basically all I need to worry about is this part here. So it becomes something like this. Okay, sine 2 pi is basically, okay, 0, isn't it? So it simply becomes pi on 4 minus 0, which is just pi on 4, and that's our solution for question 6. Okay, so does that make sense? So again here, the double angle identity transformation is the key part for this question, because otherwise the integral becomes really easy. Alright, so have a look, and let's move on. Okay, question 7 says find the integral of cos x on 2 squared dx. Okay, so how are we going to do this? Well, as usual, I'm going to start off by using our double angle identity. This time I'm going to use cos 2x equals to 2 cos x squared minus 1, because this has cos squared in it. Okay, so again I'm going to make 2 cos x squared be the subject. That will simply become cos 2x plus 1. And then I'm going to divide everything by 2, so I just have cos x squared in it. So this side becomes half cos 2x plus half. Okay, simply dividing everything by 2. Now we want cos x on 2, or basically half x, not just cos x squared. So what I'll do is divide x by 2. That means I must divide the 2 by 2 as well. So I must divide that one by 2 as well. Okay, so 2 divided by 2 is 1, so I simply have cos 1x, or cos x basically. Can you see that? So have a look. So I've got that cos x over 2 squared, okay, equals to half cos x plus half. Now that I've got that, that's what we're asked to integrate, so I'll just integrate that one like this. So that equals to the integral of this expression that we've obtained, so it becomes half cos x dx plus the integral of just half. I'm just going to separate out the integral, and then let's integrate. So this part is going to be pretty simple. So this becomes something like this. Half times cos x integrated is sine x simply, and then half just simply becomes x on 2, or half x, and then make sure you don't forget the c. Okay, that's the answer to question 7. Have a look. So I hope you're getting the hang of this now. It's very similar procedure and pattern, isn't it? Okay, so that was double angles.